The point of contact. Welcome, everyone. Let's begin our new lesson. Now, if you look at the title of today's presentation, we are focusing on the point of contact. To start, let's quickly recap what we have already learned in our previous lessons. We have already established the fundamental definition of a tangent. It is a straight line that intersects a circle at exactly one single point. As we move forward into today's topic, you will see that this specific point where the line and the circle meet is not just any random spot. In the study of geometry, this particular point of intersection is incredibly important, and because of its significance, it is given its very own dedicated name. Over the next few slides, we are going to define that name and learn how to identify it in mathematical problems. Understanding the concept. Now that we've established what a tangent is from our previous slide, let's dive deeper into the concept of how this line actually interacts with the circle. Think about it this way. When we say a tangent line touches a circle, we mean it's in a very specific position. It doesn't cut through the inside of the circle, and it certainly doesn't miss the circle entirely by floating away from it. Instead, it meets the circle at one and only one unique point. Because this specific intersection is so important, we have a formal definition for it. The unique common point where the tangent line and the circle intersect is officially known as the point of contact. To make sure this concept is crystal clear, before we move on to our real-world example, let's break it down into 4 logical steps. First, we start with the line. Let's call this line L. Second, we have the circle, a circle with its center labeled as O. Third, we look at the interaction. If we position our line, L, in such a way that it shares only one single point with the circle, then we can officially classify that line as a tangent. And finally, the identification. That one single, shared point that we just identified, that is what we designate as the point of contact. Keep this definition in mind, because in the next slide, we'll see how this looks in a practical, everyday scenario. Real-world example, a bicycle wheel. Now that we have established the formal definition of the point of contact, let's move away from abstract geometry for a moment and look at something you see every day. To help you visualize this concept, I want you to imagine a bicycle wheel resting on a perfectly flat, level road. Let's break this down using a step-by-step analysis to see how it relates to our mathematical theory. First, let's identify the circle. If you look at the outer edge of the bicycle tire, that boundary represents the circumference of our circle. Second, let's identify the tangent. The flat, straight surface of the road acts exactly like our tangent line. Third, let's look at the interaction between the two. Now, assuming the tire isn't flat or compressed by weight, the tire doesn't sink into the pavement, nor is it hovering in the air. It meets the road at one and only one single point. Finally, this brings us to our 4th step, identifying the point of contact. That exact, tiny spot where the rubber of the tire meets the surface of the road is what we call the point of contact. As we will see in the next slide, we can use this same logic to represent these physical objects using mathematical notation. Mathematical representation. Now that we have visualized the concept using the example of a bicycle wheel, let's transition from the real world into formal mathematical notation. Suppose we are looking at a diagram where we have a circle with its center labeled as O, and a straight line, which we will call xy, that is a tangent to this circle. If this line touches the circle at a specific point, let's call that point P. We can describe the relationship between these elements very precisely. First, we identify the line xy as our tangent. Following our discussion from the previous slides, we know this line doesn't cross into the circle, but merely grazes it. The point where this meeting occurs, point P, is what we formally call the point of contact. Now, here is a crucial geometric detail to keep in mind. Because point P is located exactly on the edge of the circle, the straight line distance from the center, O, to this point, P, is simply the radius of the circle. We represent this distance as the line segment OP. Understanding this relationship between the center, the point of contact, and the radius is essential, as it sets the foundation for the key takeaways and the common pitfalls we are about to discuss in the next few slides. Key takeaways. First, let's focus on the concept of uniqueness. It is vital to remember that a tangent line is special because it has exactly one, and only one, point of contact with the circle. If you find a line that hits the circle at two different spots, you are no longer dealing with a tangent, but a secant line, which we will discuss in a moment. Second, regarding the location of this point, the point of contact is never floating in space or hidden inside the circle. It always lies precisely on the circumference, which is the outer boundary of the circle. Finally, let's look at the terminology we use. In geometry, when we say a line is touching a circle, we aren't using that word loosely. We are specifically referring to that precise moment of intersection at the point of contact. Now that we have explored the definition and even seen a real-world example with a bicycle wheel, let's pause to summarize the most important takeaways from today's lesson. Keep these 3 points in mind, as they are essential for avoiding some very common mistakes that students often make when working with tangents. Common mistakes to avoid. First, be careful not to confuse tangents with secants. It is a very common error to assume that any line touching a circle is a tangent. However, if a line passes through the circle and intersects it at two distinct points, we no longer call it a tangent, we call it a secant. Always remember the rule we discussed earlier. A tangent must have exactly one, and only one, point of contact. Second, watch out for misplacing the point. Some students mistakenly believe that the point of contact could be located somewhere inside the interior of the circle. This is mathematically impossible. By definition, as we saw in our previous slides, the point of contact must lie exactly on the boundary or the circumference of the circle. It cannot be inside, and it cannot be outside. Finally, do not assume there can be multiple points of contact. A beginner might think that a single tangent line could touch the circle at two or more different spots. But in Euclidean geometry, a tangent line to a circle is unique in its interaction. It can have only one single point of contact. Now, before we conclude our lesson, I want to pause and address some common pitfalls. As you master the concept of the point of contact, you might encounter a few logical traps. Let's look at some common mistakes to avoid. Keep these distinctions in mind, and you will have a much stronger grasp of circle geometry.